Ever pondered about worlds beyond your wildest dreams? This is Planet J2407b, a young giant planet or brown dwarf orbiting the young sun-like star J1407. It lies 433.8 light-years from Earth in the constellation Centaurus. The exoplanet is 20 times more massive than Saturn, with a complex ring system 180 million kilometers wide, making them 200 times bigger than the rings of Saturn. Beyond our solar system are individual pieces of an astronomical puzzle, unlocking cosmic mysteries. They range from gas giants surpassing Jupiter's size to rocky, potentially habitable worlds. Among these, Planet J1407b, known as the Super Saturn, stands out, piquing the interest of scientists and astronomy enthusiasts alike. Discovered orbiting the young star J1407, this exoplanet is anything but ordinary. Nestled in the vast expanse of the cosmos, Planet J1407b resides in the constellation Centaurus, a striking figure against the backdrop of interstellar space. This celestial body is not just another point of light in the sky, it's a profound testament to the wonders that lay beyond our solar system. Planet J1407b is located about 430 light-years away from Earth, a distance so vast that the light we see from it today began its journey toward us in the 16th century. Its discovery in 2012 was no small feat. Astronomers, using data from various telescopes and observatories, noticed an unusual dimming of its host star, J1407. This dimming, irregular and profound, hinted at something extraordinary, a planet with a possible colossal ring system. Detecting such distant planets typically involves methods like the transit photometry or radial velocity techniques. In the case of J1407b, it was the unique light curve created by its rings passing in front of the star that clued astronomers into its existence. The data revealed not just a planet, but a glimpse into a complex system of rings that could dwarf those of any known planet in our solar system. But what truly sets J1407b apart is not just its size or its distance, but its astounding ring system. Imagine a ring system so vast it dwarfs that of Saturn's. Welcome to the mesmerizing world of J1407b, a planet whose rings extend with such grandiosity that they could almost be a celestial spectacle from science fiction. J1407b's ring system is an astronomical marvel, stretching over 200 times the size of Saturn's. Picture this: if Saturn's rings were to be superimposed on Earth's night sky, they'd be visible as a small arc. J1407b's rings, on the other hand, would dominate the heavens, creating a panoramic vista that would eclipse the moon in scale and spectacle. But the sheer size isn't the only remarkable feature of these rings. The structure of J1407b's rings reveals a complex lattice of gaps and dense bands. These gaps are particularly intriguing because they suggest the presence of exomoons, moons that orbit planets in other solar systems. These moons exert their gravitational pull on the rings, carving out spaces as they orbit the planet. This dynamic interaction hints at a celestial dance of unseen bodies, hidden within the ring's vast expanse. The density and opacity of the rings also tell a tale of their composition. Composed of ice, rock, and cosmic dust, the rings of J1407b are not merely ornamental, but are remnants of a violent history of collisions and accretion. These materials serve as a fossil record, offering clues about the early life of this distant solar system. Moreover, the impact of such a massive ring system on its host planet cannot be overstated. The rings likely influence J1407b's climate and atmospheric dynamics, casting wide shadows that may affect temperature and weather patterns across the planet. As astronomers continue to observe and study J1407b, each piece of data adds to our understanding of not just this planet, but also the formation and evolution of planetary systems across the cosmos. These rings are not just a spectacle, they hold clues to the planet's formation and the dynamics of its solar system. Living on a planet like J1407b, if possible, would be a sight to behold. Imagine standing on the surface of this colossal world, gazing up at a sky dominated by an immense ring system. These rings, stretching far beyond the horizon, would cast a mesmerizing array of shadows, creating a spectacular dance of light and darkness. Due to the sheer size of these rings, they would likely influence the planet's weather patterns in ways we can only theorize. It's conceivable that they could cause unique atmospheric phenomena, perhaps akin to perpetual twilight zones or regions with prolonged shadows that drastically affect temperature. Visibility, too, would be an extraordinary affair. The rings, composed of countless icy particles and rocks, could reflect sunlight in such a way that they illuminate the night sky, turning it into a breathtaking canvas of shimmering light, much brighter than our own moonlit nights. While it's unlikely that life as we know it could exist there, the imagination runs wild with possibilities. J2407b isn't just a curiosity, it's a window into planetary science and evolution. This distant exoplanet, with its colossal ring system, serves as a magnificent prototype for understanding not just other ringed planets, but also the broader mechanics of planetary formation. Imagine the rings of Saturn, then stretch them out far beyond what we see in our own solar system, and you start to get a sense of what J2407b presents. Such extraordinary features provoke questions. How did such an extensive ring system come to be? What can it tell us about the conditions that favor the formation of planetary rings? By studying J2407b, astronomers can gather clues about the early stages of planetary systems, potentially observing processes that occurred in our own solar system billions of years ago. Looking ahead, the potential for future missions to J1407b or similar exoplanets is tantalizing. Advances in telescopic technology and space travel could allow us to observe these distant worlds more closely than ever before. Imagine spacecraft equipped with ultra-high-resolution imaging tools, capable of dissecting the light of J1407b's rings to reveal their composition and structure. Such missions could also test new theories of gravity and planetary dynamics in conditions that are impossible to replicate on Earth. As we continue to peer deeper into the cosmos, planets like J1407b challenge our understanding and expand our horizons. These celestial bodies are not merely points of light in our telescopes. They are the frontiers of science, beckoning us to explore and to learn. We hope you enjoyed this journey through the cosmos. As we travel through space and time, unraveling the mysteries of planets like J1407b and their spectacular features, we invite you to be a part of this adventure. If you're fascinated by the wonders of the universe and eager to learn more, don't forget to like, comment, and subscribe to our channel. Your engagement doesn't just keep you updated, it helps us bring more of this captivating content to you. Every like, every comment, and every subscription fuels our journey deeper into the stars. Remember, your likes, comments, and subscriptions help us explore more cosmic wonders together. Don't forget to engage.